Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In the last video, I have discussed about the full adder, the truth table behind it, and even I have constructed the combinational circuit for the full adder. In this video, I want to discuss about the parallel adder. I request everyone to watch the complete video related to this one so that you will understand all the concepts behind the parallel adder and its drawbacks also. So now let me define what is a parallel adder. It is a digital circuit capable of finding the arithmetic sum of two binary numbers whose length is greater than 1 bit. Now if you see the off adder, if I have A0, A1, A2, A3, 4 bits are there. Similarly B0, B1, B2, B3, then how is the sum will be performed? First you will get S0 and you will get the carry, and then you will get sum, you will get the carry, sum, and the end carry you will get it. Am I right or wrong? Using off adder, we can perform the addition between two 1-bit numbers A0 and B0 like that. Coming to the full adder, we can perform the addition of 3 bits whose length is 1, such as C0, A1, B1, C1, A2, B2, like that. Only one we can perform, means length 1 only we can do. Is it clear? Are you able to understand? Using off adder, we can add 2 bits whose length is 1 only. Using full adder, we can perform addition of 3 bits whose length is 1. But if I want to add A and B whose length is 4, meaning is that they are binary numbers such as A0, B, A1, A2, A3, then how to add it? Then the parallel adder is required. Is it clear? It is a digital circuit capable of finding the arithmetic sum of two binary numbers. A and B are the two binary numbers whose length is greater than 1 bit. If you see that A0, A1, A2, A3, whose length is 4 bits. So we can add this A and B whose length is 4 using the parallel adder. Okay. Now you can ask me how it will perform. If you want to add 4 bits binary numbers, then you need 4 full adders. Why? If you see that A0, B0 is there, then you are getting the sum and you are getting the carry. And then A1, B1, you are getting the sum and you are getting the carry. You are adding A2, B2 and you are getting the sum and you are getting the carry. Again you are adding, you are getting the final sum and the end carry. Am I right or wrong? So how many full adders are required? Even one off adder is required and 3 full adders are required, but I will consider them as 4 full adders because initially we don't have any carry here. Using the off adder we can do, using 3 full adders I can do, but for a generality I will take all as full adders. Is it clear? A n-bit parallel adder requires n full adders. Is it clear? I hope you have understood. So let me draw a circuit for the 4-bit parallel adder. Okay, so that you will understand the concept in a better way. Okay, so I will take A0, B0, one full adder. Okay, for that one I am giving the carry. This carry will be always 0. Okay, then it will give the sum. Okay, and you will produce a carry also. Let me take this one as C1. Okay, then again give to the full adder, another full adder, A1 and B1. When you are adding, you will get the sum, you will get the carry. Am I right or wrong? That carry you give to another full adder. Okay, again it can perform A2, B2 with this carry. Is it clear? 3 bits you are adding and you will get the sum, you will get the carry. Is it clear? Again you take a full adder. Okay, perform the addition between A3, B3 and C3, you will get the sum S3 and you will get the final carry which is C out. So this is the a 4-bit full adder. If you want n bit, you will take n full adders. If you want 8 bit, then you will take 8 full adders. Is it clear? I hope you have understood. That is this point. A n bit parallel adder requires n full adders. Is it clear? Now we will discuss what is the drawbacks in it. Each adder has to wait. Suppose let's take this adder. Okay, let me take this adder. Okay, let me write adder 1, 2, 3, 4. Okay, now this full adder 3 has to wait for the carry from the previous adder in the chain. If it has to perform the addition, it should get the C2, A2 and B2. A2 and B2 is there, but it has to wait for this C2. How it will get the C2? It has to get from this one. But how this one will give this one? It has to get the C1. Am I right or wrong? So, if it has to perform the addition, it has to wait for the carry C2. This carry C2 will be depend on the previous adder, but it will not only depend on its only. It depends on the C1 also. Then it has to perform the addition. Are you able to understand? So, each adder has to wait for the carry from the previous adder in the chain. If, let's take that, the another drawback is that if you have 10-bit adder, then the 10th adder has to wait for all these carries. Am I right or wrong? Because suppose let's take this 4. If it has to perform the addition, it has to wait for this C3. Then it has to give, then it has to wait for C2. Then it has to perform, it has to wait for C1. Then the propagation delay is increasing. Instead of propagation delay, I will say that the delay is increasing. Am I right? The delay will be depend on this carry, how many previous adders are there. If the number of previous adders are more, the delay will be more. That is the second drawback. I hope you have understood what is a full adder and what is a parallel adder, how many bits full parallel adder, then how many full adders are required, what is the combination circuit for the full adder, what are the drawbacks. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.